Now, example number 2 spells out, before we do example number 2, based on what we just did, let me write down a couple of things. So, for example number 2, in the green box to the right, let me write it down in green. Right above example number 2 in your textbook, it goes through some of these scenarios, like log base b of 0, log base b of 1 is equal to 0, always. Log base b of b is equal to 1. Log base b of b to the y is always equal to y. Okay. This one I'll explain that one in a second. And now here's another one. This is a variation of that, which would be log base b of log base b to the x. Well, that just equals x. And that's, well, you know what, let me prove those to you. Let me prove those to you, and then I'll erase it, okay? So, on your paper, maybe, how would I do that? Yeah, let's do it on the top, and then we'll do example number 2 on the bottom. So, I want to show these to you first. So, if I say log base b of b to the y, and it equals y, remember that we're saying y is equal to the log base b of x, okay? And that relationship is b to the y equals x. Or in this case, it would be b to the y equals b to the y. Okay? And so, if b to the y equals b to the y, that's a true statement for any y. Pick a number for y. 6. True. B to the 6 is b to the 6, right? Pick another number for y. 517. Correct. If b to the 2 equals b to the 2, b to the 15 equals b to the 15, b to the 7 equals that. So no matter what I plug in, it'll make the statement true. Okay? So that's why this one's y, because whatever y is, you know, it's a true statement, right? Now for the next one, for this one here, this one's a little more complicated. Do you guys have this written down? Yeah, I'm just going to erase it because I'd like to keep everything on one page so you guys can see it. Now this one's different. We said b to the log base b to the x is equal to x. Now remember, and I wish that your textbook would have used like different symbols or something, but we said that b to the y equals x, right? So in this case, what is the y term? So, and then we also said that log base b to the x equals y, right? So now check this out. What is this? This is my y term right here, right? So what I'm saying is log base b to the x is equal to y, which is equal to this. Log base b to the x. All right. You guys did such a good job with the y's. Pick out a number for x.
5.
5. Log base b of 5 is equal to log base b of 5. Pick out another number.
50.
Log base b of 50 is equal to log base b of 50. So do you see there, no matter what x value I plug in, the statement's true?
Correct.
Correct. All right, so you guys have this written down? So this is all for example number 2. Now we're going to do example number 2. It's all in your textbook. If you were missing a letter or something, it's on page 301. Okay. So now for example number 2, they give us they say log log base 2 of 8 is equal to, now here's another way that you could write it. This is a technique that's pretty snazzy. If we use this property, if I could take the number 8 and rewrite it in the base of 2, then I know what the answer is. In other words, if I say that this is log base 2 of 2 to the third, right? Because isn't 8 2 to the third power? Well, kind of, and I'm going to use some informal teenager. I'm in high school. I'm on Twitter and Instagram 24 hours a day, 7 days a week language. These cancel, sort of, and I'm left with 3, right? Because that's based on this property here. Does that make sense? So let's do the next one. If I say log base, these are just the same examples from example 1. I could rewrite that as log base 3 raised to the 1/2. What's the answer? 1/2. If I say log base, oh wait, this isn't a log, this is an exponential. Ready? This is going to be awesome. 6 log base 6 of 11. Now, the only difference between that one and the first two is that we're going to use this property. And according to this property, what should my answer be? 11. Very good. That's example number 2. Do you guys have any questions on that?